Hey, hi everyone. This is Sai from Let's Upgrade. So let's talk about how to get your certificate. It's very simple. You will see two links in the description. Number one is the place where you have to go and mark your attendance. Marking your attendance tells us, like, okay, you are a legit student who have attended this particular session. Link number two is your assignment. This is where your 90% of the priority is. You have to go and submit the assignment that is given to you in this particular session. Once you're done submitting that assignment, we will be evaluating that. We will send you an email. If you get the passing criteria, then only we will give you the certificate on a particular date that is mentioned again in the description. Please check these three things, and this is the way how you will get a certificate from Let's Upgrade. Number one, mark your attendance. Number two, just go ahead and upload your assignment. Check for the email that you have received it, yes or no. What is the feedback that you have received from your trainer? Number three, check on which date the certificates will be released. Thank you. Bye. All the best. Happy learning.
All right, students. Hello, everyone. So we can just get started again with further more concepts. So let me just revise the previous part what we have done in the previous session. Last thing that we have done is introduced. What I have done is introduced you to the linked list. So we are actually getting started with the linked list data structure. And last time, what I have told you was that linked list is another very important data structure whose questions might definitely be there in a pretty good interview. Okay, so it's very important to learn about this data structure as well. Apart from that, it's actually one of the simplest one as well. Once you understand what exactly class, oops, and this particular structure which I'm showing on the screen, how exactly this works. Once you understand how this works, you will be it will be pretty straightforward for you to understand that. Okay, let me just give you a quick revision here. That is, in linked list data structure, we always have a node. This is what we call a node. You can either draw it like this, or you can draw it in a circle as well, indicating data and address. This is also you can draw it when you are writing down your notes. That is totally up to you. It's your choice. But right now I am going to draw it like this only. That is, this is what you call a node. And in a linked list, we have two of the values inside a node. One is data, other one is address. Data is simply the value which will be used to get manipulated in a different ways to solve different problems. Okay, and address, on the other hand, what exactly is the address? Address is the location of the next node that you're going to be pointing to. That means, let's suppose this is the initial node that we have. This is the first node that we have. It is going to have one value. Let's suppose it is 5. And other thing, inside this box, inside the smaller box, there will be address. That address is generally in a hexadecimal form that will look something like this, like H5237, something like this. A random value you might see, something like that. It will look like an address. That address is not actually the location of your current node. No, it is actually the location of your next node. That means whatever address we have here, let's suppose we have address as 1000, then that 1000 is the address of next node. 4, then we have the next node. We have this arrow pointing to the next node, which is telling us the location of the next one, so that we can directly jump to the next part itself. Once we reach there, again we have a node which is having value 4, and it is also going to have one address. Let's just suppose it is saying 1050. It is having address 1050. I'm assuming this is not an absolute value. I'm just giving an example. Let's suppose it is having address 1050. Then this 1050 is actually the address of next node. This node is having address 1050, and this node is having address 1000. This also might be having some address like 900 or something like that. Then again, next node is having -2 value and an address. Let's just assume it is 2000. So this 2000 is the address of next node. Again, it is having one value, and other one is the address, because this is the very last node of your linked list. That means it will be having exactly null pointer as its address, as the address of next node, indicating that this is the last node and you cannot go anywhere from here, because right here you have ended the process right here. Okay, let me just remove these additional things it so that will look much clearer. Let me just create a new. Let me just clarify another simple thing here. Linked list is the concept, but there are different type of linked list as well. Let me give you in short as well what exactly is that. First one is actually the singly linked list. What does it look? This is exactly what a singly linked list looks like. Let me just draw in front of it. Let me just draw the structure of singly linked list in front of it. This is what singly linked list looks like. All obviously it will be containing some values 1, 2, 3. Okay. When one node, initial node will always be pointed at head. And singly linked list looks like this. When one node is moving to the next one, here point is you can move from one node to next node, but you cannot come back. These arrows which I'm creating is actually indicating the direction where you can go. If you are standing at index, let's suppose if you're standing at node 2, so from here you can only go to 3. You cannot go to 1. Okay, as simple as that, because arrow are telling us that here from here you have only one direction to go. Second one, what do we have is doubly linked list. Now what exactly is doubly linked list? Well, it is also same only difference is in doubly linked list you can move in both directions instead of one. What does it look like? Let's suppose you have 1, you have 2, you have 3 here. You can definitely go in the forward direction, but along with that you can also go back. That is also allowed in doubly linked list. Obviously this one should be pointing to some next one, which will be null ptr, and this one also should be pointing back to something that is also null ptr, null pointer. And same as that, here we have had as well on one more is circular linked list. Now what exactly is circular linked list? That is also pretty straightforward only. Let me show you the structure of it. Let's suppose you have 1, 2 and 3 nodes. Okay, obviously you will be moving in the forward direction just like the singly linked list, but along with that at the end of the 3 you will not be pointing to null ptr, but instead you will be pointing back at 1. This is what you call a circular linked list, because as you can see from the structure itself, it is actually moving in the circular manner. You are starting from the beginning from 1, going to 2, going to 3, and then again getting back to 1. That is what you call a circular linked list. And there is one last one. Obviously, I think you can guess, circular doubly linked list. And I think you can easily guess the structure of it as well. You have 1, 2, 3. Obviously, you can go in the forward direction. Because it's doubly linked list, you can obviously go back as well. But along with that, it is circular as well. So from here, instead of pointing to null, it will be pointing back to 1. Also, instead of 1 pointing back at null, it will be actually pointing to 3. So it will be circular in both directions. Just like that, there are 4 type of linked list. You can just write down these types of linked list, and then we will move further. Let me just store this, write it in the next page so that it will be much more clearer. Yeah, here you have types of linked list. Please take a second to note down this thing. All right, I hope you must have noted it down. So apart from this, there is actually one more important point that I would like to mention to you regarding linked list. This is one advantage I wanted to let you know about linked list. Well, someone might ask you in an interview or somewhere else, anywhere else, that what advantage do we have of linked list over, well, that is a very genuine question, that if we already do have array, why exactly are we even considering using a linked list data structure? If we have array, we can use it in the exact same way and it will work exactly same. Then why exactly we are using linked list? Why exactly even we have linked list, right? Let me tell you the difference between first of all arrays and linked list. Only the most major actually, the most major difference between arrays and linked list, I think most of you would already be aware about it, but let me just clearly mention it. Continuous memory allocation, that you're already aware about, whereas linked list is not. This one is not continuous memory allocation. What exactly do I mean actually? Here I would like to underline this word continuous. Let me explain this one sentence to you in a very short way. All of you are aware about that in our system we do have some memory, correct? Our system always have some memory. Either it can be, I think, some of you might be having 250 GB of memory. some have 512 as well, correct? Some have 1 TB space as well in your system, correct? What exactly does that mean? Well, whenever you have some space in your system, it actually looks like a grid behind the scene. That means inside your system, it will look like a infinite size grid. This is what it will look like. Let's just assume that, okay? When you are using an array, let's suppose you are creating an array. I am assuming, let's suppose 13 size array. 13 size array you are creating. What it will happen in that case is computer will simply pick one address. This is an infinite grid. Each box is having its own address. Each box is representing a memory location. So when you're creating an array at a particular index at of 313 size, so what it will do is it will simply pick one address. Let's suppose it is picking 1000 address. Then it will take 12 more locations right in front of it. It will simply occupy all these spaces. So now you know address of the zeroth index of an array. Next one will be 1002. Next one will be 1004. Then 1006, 1008, 1010, 1012, 1014, 1016, 1018, 1020, 1022, 1024. It will occupy all these spaces. That's what it will do. It is going to take continuous memory allocation. Whereas, let's suppose right now I'm talking about linked list. When you are creating a linked list of, let's suppose, 5 size, what it will do is it will pick any random address at any random location. Let's suppose this one, which will be the zeroth index, which will be the very first element of linked list. Then it will pick the next one randomly. Let's suppose it picked this one. Then this will be the second index. This will be the second element of the linked list. Then again it will pick a random one. Let's suppose it picked this one. This will be another random index, another element. Let's suppose it again picked, let's suppose here. Then fifth one, let's suppose it picked right here. That's exactly how linked list works. That's exactly how the structure of linked list actually looks like behind the scene. And this structure, how linked list is arranged, actually makes it much more is efficient. So here you got the answer. What exactly is the advantage do we have of linked list over array? We have it much more space efficient. Well, how exactly am I saying it is much more space efficient? Well, let's just assume actually grid size is very, very big. But if you assume, let's suppose you have your grid looks like this. In case, assuming as of now, let's suppose this is how your grid looks like. And I created array of 3 size. Created array of 3 size. What it will do is it will pick this address, pick this one, and this one. Correct? These 3 addresses it will pick. Let's suppose now I again want to create an array of 2 size. Think about it. Can you start your location from here? No, actually, because there is no next element, there is no next location. You actually have to start it from here and then pick this one. That's how you will create the second array. What happened in this case? This location is wasted now. This location is wasted now. But in the on the other hand, let's suppose I say linked list, create a linked list of 3 size. This will consume all the required space. Let's suppose it picked this one first of all, this one first of all, then it will pick this one, and then it will pick this one. So that's how it will arrange its elements like a way so that it will be much more space efficient. That is the main advantage that we have of linked list over array. Okay, please make sure to write that down in your notes in your own language. I'm not saying to draw a grid like this. If you want, you can definitely, but make sure you're writing these things down in your own language in your notes. So I hope आप लोगों ने you guys must have written these notes down in your own language. Now what we'll do is we will just try to perform one of the question of linked list so that it will get much more clear. And we are going to perform the most important and most you may say easiest as well or most important as well question of the linked list topic. Okay, it is the most famous one. Lot of time this question is being asked in interviews, so that it will be much more better if we practice this question itself. Okay, question is not very long. We have to simply write a program. We have to write a program to reverse a linked list. First of all, let me just tell you how exactly linked list will look like if we reverse it. First of all, let's suppose we have got an input which look like this. We have one node, 1. Let's just say its value is 1. It is pointing to the next node, 2, pointing to the next node, 3, pointing to the next node, 4, and pointing to the next node. Actually, one thing I think I forgot to mention here is that in arrays I have told you that every time you create an array or a string, it will always have indexing in it. Correct? That's actually not true for linked list. Here, linked list concept does not have indexing. It is not like you can name it 0, 1, 2, 3, imagine it. No, you don't have to imagine it, and here is no need of indexing as well, okay, because every node is pointing to the next one already. You know the location of every node one by one, so there is no need of indexing. That's why linked list does not have indexing concept at all. Okay, all right, moving to the question. This is how our input linked list looks like. That is, you will be having a head pointer pointing to the very first node, and then every node is pointing to each of the next node till you will reach till the null pointer. That means end of the linked list. What you will be given in the program is, what you will be given in the question is this head. You will have this head, you will have this head, and through this head pointer you can access the entire linked list. Okay, let's suppose we have done reversing the linked list. Then how our output would look like? Our output would be something like this. This will be your output that is expected from you to return. You have to return the head pointer, which should be pointing to the very last node of your original linked list. That means 5. And then it will be moving in the backward direction up till you reach the null pointer. That's what is expected from us. It will be pretty straightforward. Let me just show you the dry run first of all, that how exactly we are going to achieve this. After that only we will move to the actual code. Let me just move this head somewhere else so that we can give a proper dry run. Okay, this is what we have. All right, now what we will do is we will be keep on doing the dry run. Along with that, we will be keep on writing the pseudocode as well. Let me just write down code right here. See, what we will do is, first of all, we will create a current linked list, sorry, current pointer. All right, let's just write it down. Create a current pointer. Done it. Okay, we have created the current pointer at head. Done. Second, we will create a previous pointer which will be pointing to the previous node. Done. After that only we will start working on the execution. Let me just draw the previous pointer as well. Iterate over linked list until reached null ptr. That means keep on running on the linked list until you reach till the very end of the linked list. Done. All right, now what exactly do we have to do in each step? हर step में क्या करेंगे? Okay, what we will do is, we have this scenario right now. In each step, that means inside the loop, we will first of all create a future pointer. Done. I have created a future pointer pointing to the next node of the current. Using these three pointers itself, we will be solving the entire question. Using this three pointer only, current, previous, and future, we will solve the entire question. See, let me just write that down. Create a future pointer. Done. Now, what I will do is, I will destroy this particular bond. I will simply destroy this particular link, and once I do it, this connection is lost, and now this entire linked list is separate from this node. That is why I have created the future pointer, so that it won't be lost. That is a very important point to note. Once you destroy a link, then remaining linked list will be having no way to access it until you have a future pointer. That is why creating a future pointer first is very important. Okay, once done that, I will destroy this pointer and point my current pointer to the previous. Let me just write that down so that it will be clear in your mind. Delete link from, or I can say, instead of deleting, I can say move pointer of current from future to previous. As you can see, मैंने क्या किया है? I have simply moved this particular link which was going from 1 to previous. Okay, and then move all of three together in the future direction. That means move current to future and previous to current. See, I will simply move this previous here, and I will simply move this current here. Now both are moved one step ahead. You see? Both are moved one step ahead. Again run the loop. Again run the loop. Create a future pointer. Furthermore, हमने future pointer create किया. Again do the same thing. Move pointer of current from future to previous. ठीक है. Removing this and pointing it here. All right. What is the next step? Move previous to current and current to future. Again, previous to current, current to future. Very nice. Again do the same thing. Again run the loop. Create a future pointer first of all. Okay, we have created a future pointer here. As you can see, it is our window which is moving from one node to another one by one. Again do the same thing. What is it? Move the pointer from future to previous. All right, move the pointer from future to previous. As you can see, up till now, 1 is pointing to null, 2 is pointing to 1, 3 is pointing to 2. We are going like that. Okay, what is the next step? Move previous to current, current to future. Exactly what I said, exactly what I have written. Again run the same loop and do the same thing again. Create a future pointer. Done it. Again move pointer of current from future to previous. All right, removing this, pointing it here. Correct. What is the next step? Move previous to current, current to future. Previous to current, current to future. Right. Again do the same thing. Create a future pointer. Very nice. We have created a future pointer. Again do the same thing. Move pointer of current from future to previous. ये pointer destroy करके we move it to the backward direction. Very nice. Again do the same thing. Move current to future and previous to current. We move previous to current and current to future. Now if you check the condition of the loop, iterate over linked list until reach null pointer. As you can see, your current is right now pointing at null pointer. It has ended the process, loop is ended, and we can simply return our answer and we have finished the process. As you can see right now, our expected output and our dry run linked list looks exactly the same. 1 is pointing to null, yes it is. 2 is pointing to 1, yes it is. 3 is pointing to 2, yes it is. 4 is pointing to 3, yes it is. 5 is pointing to 4, yes it is. That's it. We can end this process and let's just write down the code right now. We can simply move it to code. All right, so let's just do one thing, because this is a very famous question. Why don't we just use any online platform to submit this question? My most famous platform is actually LeetCode, so why don't we just submit it there as well? So here I have opened the link for our LeetCode platform where the question is same only, reverse linked list. Okay, here as well question is given as same only. We can just see the question first of all, that is, given the head of a singly linked list, reverse the list and return the reversed list. Okay, here also example is same only, 1 2 3 4 5 is given to us and we have to return 5 4 3 2 1, exactly what I explained. All right, so let's just use our pseudocode and try to solve this question. C++ language I have selected. All right, so it is also showing us here that how exactly our list node looks like in a comment. It is showing that in a list node, that means a node, we have a value and we have a next pointer. That's exactly what it is saying. These all are constructors only which are necessary for a class to run. Okay, so according to our pseudocode, what exactly do we have? Let's just read the pseudocode one by one and write the same thing. Create a current pointer at head. All right, here head is given to us. Let's just do that. We have created a list node. Call it as current, and it is starting from head. Correct. All right. What is the next step? Next step is create a previous pointer. So here we have created a list node, name it as previous, and pointing it at null ptr. Steps are completed. We have created current pointer and previous pointer. Then it is saying to iterate over linked list until you reach null pointer. So let's just run a while loop here, which will be having condition until your current is not equal to null pointer. That means until your current pointer is not equal to null, keep on running. Keep on running and keep performing the same steps as mentioned. First step here is creating a future node. Let's just call it as future, pointing at current next node of the current one. As you can see, whenever I am creating a future, it was always one further of the current node. As you can see in the recording, by reversing every time, what do we have to do? We have to move our current pointer from future to previous. So current next should be pointing to previous. When you move one pointer to previous, it will automatically get removed from the future. So you don't need to destroy it specifically. You can just simply move it from future to previous. Once that is done, you just have to move the pointers as I have mentioned in pseudocode. Previous will be moving to current and current will be moving to future. That's how it works. And once it is done, as you can see, you have to return the head pointer, which will point to the last node. Which pointer right now you can see is pointing to the last node? The previous pointer. Previous pointer is pointing to the last node. So that's exactly what we can return. Let's just here return previous pointer. Let's just try to give it a run. As you can see, first three test cases are simply getting passed. Let's just try to give it a submit. But before that, there is one base condition you should know. What will happen in case when you have only one size of linked list or maybe null size of linked list? In that case, you cannot reverse it. So we can simply mention it here at the beginning. If head is equal to null pointer, or if head dot next is equal to null pointer. That means it is either zero size or one size. In that case, you cannot reverse it. You can simply return head itself. I mean same linked list you can return. That will work. Let's just submit, and it is getting passed, beating 100% of the other users. Let me just add this code in the notes for your future reference. So that's how exactly linked list works. Now let's just move it to the next topic. Let me give you a brief introduction on another important data structure, which is stacks and queues. First of all, basic thing. Let's just get started with stack. What exactly is a stack? Well, if you look at the English meaning of what stack is, it's actually a structure which is saying one element on top of other. That's what a stack is. If I say, let's suppose here is the ground we have. Let's suppose there is a book, mathematics books is placed here. Then let's suppose we have English book on top of it. Let's suppose then we have physics. Let's suppose after that we have chemistry. This is what you call a stack, when you have placed many elements on top of each other. Just like a chapati box. When in a chapati box you place multiple chapatis, and the main functionality here is whenever you try to have a chapati out of a chapati box, you will be able to access the top element only, topest chapati only. That's what a functionality of stack is. Whenever you place some elements, you always place it from the top, and whenever you try to remove it, you will get the access of the topest element only. Let me show you an actual structure of stack here. This is what a stack is. One point to note here is we don't have indexing here as well. Here there is no point of giving any indexing to any element, because no matter what, you will always be able to access the topmost element only. If you want to add some element, you will always be able to add it at the very top. If you want to remove something, you will always be able to remove it from the very top. Okay, so that is one functionality that we have. That is the most major functionality that we have, that makes it stack. Let's suppose I have a stack of type int, integer type of values it is storing. So it can store, let's suppose, 5, 2, 3, 4, -7 and 1, any random numbers I have given. Let's suppose if I wanted to remove some element, so only element that I can access is this one. I can only be able to remove 1. Unless I remove 1, I will not be able to remove -7. Once I remove -7, only after that I will be able to remove 4. And same goes like that. If you have added 5, whenever you adding another element, let's suppose 2, it will be always on the top of it. Okay, this is what you call, this functionality is called as LIFO. You might have heard about it. Full form is last in first out. That is what simple functionality of stack is. So this is what a basic introduction of stack is. Now obviously we need to perform some operations on it. There are majorly three operations only. Three operations only. Let's just say inbuilt functions. So in a stack, you already know that you can only access the topmost element at any time. So how do you add an element? How do you add an element in stack? How do you remove an element from stack? What else you can do? If you have only access to the topmost element, what else you can do? Either you can add some element, you can remove some element, or maybe you can simply access top element without removing it, of course. These three are the only operations which you can do on a stack data structure. And for each of it, you have one operation for it. You have one inbuilt function for it. Let's just say we have created this stack and name of this stack I have given as st only. In short of stack I have given st. What it will do is we will use three inbuilt functions. How do I add an element? I will simply say st dot push, and then inside it I can place any number or any value. It will simply add the element at the topmost part of the stack. Okay. How do I remove it? I can simply say st dot. This will simply remove the topmost element of the stack. Only the topmost one, nothing else. And how do you see the topmost element of the stack? You can simply say st dot top. This will give you the access of the topmost element of stack without actually removing it. Okay, that's how we do it. One small other thing is how to declare a stack. We haven't declared it yet. It's a pretty straightforward thing. You can simply say stack in small s in triangular braces, triangular brackets. You can simply mention the data type, what type of stack it is. With some space, you can say st, and that will be done. That's how you can simply uh, declare a stack. This st, I have given the name of the stack. You can give anything else that you like. I have given st for general reference. Okay, let me just rearrange it in a better way. I think that's fine. So here I have given you a brief introduction of what stack is. Similarly, let's just go ahead and explain you about the queue as well. That is also pretty straightforward only. That is why these two topics are together. Queue is another similar type of data structure, but this one is actually open from both end. Instead of one, it is open from both end. This actually follows the functionality of FIFO. Might have heard about it. What is the full form for it? First in, first out. Okay. What's exactly the structure of queue looks like? If you want to imagine it, how will you imagine this? You will imagine it like this. Yes, you can simply imagine this queue like this, where you can obviously again place some elements. Let's suppose I have placed 5, 2, 3, -1, 0, 7, 8, something like this. One another note, that is, here also we don't have concept of indexing. Correct? Here also we don't need any indexing at all. So in the stack, you are able to add an element at the very top only, and you are able to remove the element from the same very top as well. But in the queue, because it is open from both end, you can simply imagine it like a tunnel. Correct? You can imagine it like a tunnel, like one tunnel, there's a tunnel and there's cars going on one by one inside the tunnel. uh, the very first car that enters the tunnel will be the very first car that gets out of the tunnel. Correct? That is what first in and first out functionality is. Similar to that, if I want to add some element, I will add it from the front, and if I want to remove some element, I can remove it from the rear. You add the element from the front end and you remove the element from the rear end. That means in this queue, the very first element that enters the queue, entered the queue, which one is it? That will be 8, because that is the very first element which are about to get out as well. Correct? If you see, what is the first element that gets out of the queue? If you imagine it, imagine all of these like a car. So what is the which car is at the very front? Which car is about to get out of the queue? This is 8. That is why 8 is the number which entered the very first time. That is what queue functionality is. That is what queue data structure is, and that's how the structure of queue looks like. Now, again, similar to stack, we do have some inbuilt functions to operate on it. Okay, let's just talk about some inbuilt functions of it this time. Before starting the inbuilt functions, let me tell you how do you declare a queue. In C++, that is also very straightforward only. What you have to do is you simply have to say queue with small q, and inside triangular brackets, you can simply mention the data type. That is what type of queue you want to create. Do you want to store the numbers inside the queue? Do you want to store the boolean value? Do you want to store the string type of values, or any kind of value? Okay, I am going to name this queue as QUE. That's it. As straightforward as that. That's the only thing you have to do to create a queue. Now, what are the inbuilt functions that we can use? Let's see. Let's just look at the structure first of all. Very first two operations are very obvious. That is inserting some element and removing some element. Correct? Inbuilt functions for those are absolutely same only. Add an element in queue. How do you add an element? You can simply say queue dot and inside it some value, whatever value you want to add. That's it. You can simply say queue dot push, same as stack, and it will add the element at the very front of the from the very front of the queue. Next thing is you want to remove an element from queue. Again, you can say queue dot, and that will remove the element from the very last only. Let's suppose if I have added, let's suppose instead of x, I say 8 I have added. That's what I wanted to say. Now, where exactly this 8 will be added in the queue? Will it be added here or will it be added here? Because obviously in between you cannot add anything. It will be added right here. Okay. Let's suppose you have popped an element out of the queue. In that case, what will happen? In that case, this particular element, this particular 8 will be get removed. Okay. Now, obviously, in stack, you are able to access the topmost element of the stack. Correct? Here, this time you have access to both of the ends. So what you will do right now is you should be able to access both of the ends. How do you access element in front of the queue? Another thing is how do you access element in rear end of the queue? Pretty straightforward here as well. That is, you can simply say queue dot front. This will give you the access of the very last element. That means last element as in this one, which is on the very left, without removing it, of course. And how do you access the rear end? Q dot rear. That's how you can access the very last element as well, obviously without removing it. As simple as that. This is one basic overview of how exactly queue looks like. Now you have a basic idea of stack and a basic idea of queue as well. Sorry, one point I would like to correct here is in the rear end, you don't say rear, but the inbuilt function name is back. Now it is correct. All right, just make sure to write this thing down right away. Now, if you have written it down, why don't we just simply perform one straightforward question, one simple question regarding stack and queue? Generally, because there are many foundations in stack and queue, that is, you can only enter element at the very top of the stack. You can only enter element from the front of the queue and get it from the out, get it out from the rear end. So that's why there are very specific functionality, very specific questions are there, which will needed help of stack and queue. So one of the very famous one of those is write a program of reversing a string using stack. That is one question which is very famous for using stack itself. This question you have done already, but that was that time we are not using stack. This time let's just do that. Let's suppose I have one input. I am going to say I have one string A, B, C, D, E. Can you tell me this that if the string have indexing or not? Yes, it does. So I will just mention it as well. Now what is expected from us is what our output is. Our string should look like this. E, D, C, B, A. You already know that. Indexing, I will just mention again. So how exactly can we do that using a stack? Well, as you can see, as you already know, I'm repeating same thing again and again. That is, you can enter element at the very top, you can remove element from the very top only. That is what functionality LIFO is. So I think this thing can be used to reverse a string. Let's see how. If we do a small dry run here, let's suppose what I did is I have created a stack. I have created a stack here. All right. We already have our input string here. Let's just take it right here. So first question is, what exactly are we going to input in that string? Input in that stack, sorry. What exactly are we planning to store inside that stack? Obviously, whatever is inside this, correct? Do we have numbers inside it? No, we don't have numbers inside it. In string, we have a character. So that's why this stack should be of type character. I have created, let's suppose I have created a character type of stack. Now what I will do is, obviously, I will traverse from very start to very end in string. At the very first time, what exactly do we have? We have a character small a. I will place it inside the stack. Done. Keep on moving. You move to the next part. Now what do we have inside the string? We have character b. Place it inside the stack. You mean to say push it. Push it inside the stack. What next do we have? We have small c. We have pushed small c inside the stack. Then again, what is the next element do we have? Small d. Push that inside the stack. What is next? What is the next thing that we have? We have small e. Push that inside the stack. Once this process is done, as you can see, we have created our stack. What you can notice here is now when I will try to remove some element, the very last element that I will get access to is small e, which is in reverse only. Why don't we do this? Now if we remove elements from stack, that means pop. Inbuilt function is pop element from stack. The very first element that I will get is small e. Let's just print that. We have removed it and printed it. Very nice. Now what is the next element we have access to? Small d. Let's just remove that and print that. Now what is the next element that we have access to? Small c. Very nice. Then we will print that and remove it. Let's just write down the pseudocode as well alongside. Huh? What is the first step that we have done? Think about it. Obviously create a stack. We have created a stack first of all. Next thing is we have iterated over what? This. To push the element inside the stack, you need to iterate over string. Iterate over string. Keep pushing elements inside stack. Done. Once that loop is done, you have placed all the elements inside the stack. Now what is the second third thing comes in mind is removing these elements. Now we are iterating over stack. Until when? Until until stack is empty. Until the stack become empty, we will be keep on iterating over it. Inside this loop, I will be printing each element. Printing each element. Correct? Same thing I have done again. C I have printed and removed. Then what is the next element that we have access to? B. Printed it and removed it. Then what is the next element we have access to? Small a. Printed it and removed it. Now your stack is empty. So now you can safely say that yes, this loop has ended, this stack is empty. We can end the process because we have printed the reverse string already. Correct? I would say this would be very easy code to do. Let's just quickly do that. This time, let's just do it in console. All right, let's just zoom in a little bit. That is done. Couple of small things hash include iostream using namespace std. Done. Now here, what we have to do is, first of all, we have to input a string, correct? So let's just create a string of str and input it. Done. We have inputted the string. Now, whatever next step is to create a stack. Now the pseudocode has started already. Create a stack. We have created a stack of what type? Of character type. Let's just name it as st. Done. Right now this is an empty stack. That means initially its size is 0 only. Now iterate over string and place all the elements inside the stack. How do you place elements? By saying st.push. Now each character I have to access, right? How do I access each character of string? Str square bracket I. Now it is time to remove those elements. Keep on running the loop until the stack is empty. Until your stack size is greater than 0. Until we have some element inside the stack, we will be keep on running. Let's just access the topmost element. How do you access the topmost element? Obviously, you're right, by saying st.top, correct? That's how you access the topmost element. Once you access and printed the element, you simply need to remove that element. How do you remove it? Remove a topmost element? st.pop. As simple as that. Done only. Let's just try it. I think it will give error and I know why. Let's see. A, B, C, D, E. If I try to run it right now, okay, it did not give error, although it has to give because we haven't included our stack here. This has to be included when you are doing in IDE. This should be necessary, but here in this case it is not. It has reversed the string properly without any issue. Let me just add this code in our notes. Yeah, so that was actually it for our this class. I hope you have enjoyed. All right, thank you everyone. Bye bye.